Good morning, students. As we have discussed in the previous class about the relation between radius of curvature and focal length for concave mirror, so today we will discuss about the same topic, but it will be for convex mirror. So again, headline: relation between radius of curvature, that is R, and focal length small f. This time it will be for convex mirror. We have discussed in the previous class for concave mirror, and this time it will be for convex mirror. Relation between radius of curvature R and focal length f for convex mirror. Note down the headlines. Now for this thing, we will consider a convex mirror. We will consider a convex mirror. We know what is convex mirror, how to draw it. So let us consider a convex mirror here. Okay, this is going to be a convex mirror for us. You know, convex mirror reflecting surface is curved outward. We have studied all this thing in the very beginning. So this is going to be your pole of the principal axis. Sorry, this principal axis. So this is principal axis. This is your principal focus, and this will be your center of curvature. So if I consider a ray is coming from the infinity like that, so it will be diverged by this way. Okay, we have studied all this thing, so I think we have no problem to identify the diagram. This will be the direction. Okay, so let us suppose this point to be A, this point to be B, and if I draw a line from the center of curvature, if I draw a line from the center of curvature, the distance I can show like that. So okay, that means this will be your angle of incidence and this will be angle of reflection. Understand? Same thing. So one thing you mind, if this is angle of R, this is also going to be angle of R. Vertically opposite angle. Okay? So I can write from the diagram. First thing you can write that angle I is equal to angle R. I should not tell you, know it, why it is equal. Angle R is equal, I is equal to angle R. This angle and this angle equal. Why? Because this is by the law of reflection of light. Which angle? This angle I is equal to this angle R. Next, as I told you, if this angle is R, this angle will obviously be R. So you can write angle R is equal to angle R. This angle R is equal to this angle R. Why? Because they are vertically opposite angle. They are vertically opposite angle. Who are vertically opposite angle? This is angle R is equal to angle R. So one more thing, if this angle is I, this angle is also going to be I. Okay? If this angle is I, this angle is also going to be I. So I can write again angle I is equal to angle I. Why? The very simple thing, they are corresponding angle. They are corresponding angle. You mind the point. See, first thing again, this angle I is equal to this angle R. Why? Because by the law of reflection. If this angle is R, this angle is also R, they are vertically opposite angle. Okay. If this is I, this is also going to be I, so they are corresponding angle. Okay. Now we can see a triangle. This is triangle BCF. You can write now in triangle. Which triangle? Triangle BCF. In triangle BCF. In triangle BCF, angle R is going to be angle I. Very simple. Okay, because this is equal to this is equal to this angle is equal to this angle, so angle I is equal to angle R in triangle BCF. Okay, in triangle BCF you can write angle I is equal to angle R. If angle I is equal to angle R, FB will equal to CF. FB is equal to CF. FB is going to be equal to CF. Why? Because they are the sides opposite to. They are the side opposite to equal angle. Am I clear? So FB is opposite to angle I, CF is opposite to angle R. Okay? So let us consider this is to be number 1 equation. Okay, this is number 1 equation. So now you can see, therefore triangle BCF is M. Therefore triangle BCF is an isosceles triangle because the two sides are equal. Fine. Now I am writing in this side. From the diagram only I can send you is the diagram. Diagram making is very important. Diagram should be neat and clear. Okay. Now as I told you that if I consider that aperture of the mirror is too small. Write down for small aperture. For small aperture of the mirror. For small aperture of the mirror. Aperture I told you which is aperture. This part is an aperture. Now for small aperture of the mirror, point B is too close to point P or not. This point we have discussed in case of concave mirror also. So you can write FB is equal to FP. Therefore FB is equal to FP. FB is equal to FP. Why you can write? For small aperture of the mirror, if you consider this aperture is very small, then this point B will be too close to point P. Then only you can write FB is equal to FP. So let us suppose this is number 2 equation. Now from 1 and 2. From 1 and 2. From 1 and 2 what you can find? 1 and 2 you can find FP is equal to you can write CF. This is number 3. FP is equal to CF from equation number 1 and 2. Now again all the distances are observed from the pole of the mirror. So if I find a PC here, now PC is equal to, you can write PC is equal to FP plus CF. FP plus CF. This implies PC is equal to FP. Okay? And in the place of CF, you can write FP because CF is equal to FP. So this is your FP. PC is equal to twice of FP. So as I told you, what is PC here? In this case, PC is going to be R and PF is going to be small f. This is going to be small f, this is going to be R. Radius of curvature both are positive. So R is equal to twice of F, or small f is equal to R by 2. So this is the relation between radius of curvature and focal length for concave mirror. I think these two topics is cleared. Relation between radius of curvature and focal length for concave mirror and for convex mirror. Thank you so much.